In this video, I'm going to explain how to find the area under the curve when your z-score doesn't land exactly on one of the values and you cannot use the empirical rule. So let's go ahead and read an example. The length of pregnancy of Asian elephants is approximately normally distributed with a mean of 609 days and standard deviation of 31 days. All right, so we're given a mean of 609 and a standard deviation of 31, and here is our normal model. So I can rewrite it here. We have a normal model of 609 days and a standard deviation of 31. So keep in mind, this is the population of Asian elephants. So all over this normal curve are different elephants and their length of pregnancy. So you have all of those recorded here. And then, of course, the mean of that is 609, and standard deviation is 31. All right, so I went ahead and I already made the x-axis and I displayed the mean right here, 609, and I added 31, so that would be 640, 671, 702, and then the same to the left. Now, our z-score, if you recall, always has a mean of 0. So in other words, 609 days is right at our mean, so the z-score for that would be 0. We have one standard deviation for a z-score, so this goes from 0 is the mean, this is 1, 2 standard deviation, 3 standard deviation, -1, -2, and -3. All right, we also know the breakdown of the percentages using the empirical rule, so we know that it is approximately 34%, one standard deviation left and right of the mean, and so on. I'm not going to fill out all the percentages. But now, how do we find a percentage of elephants that are lower than 620 days? So now we see that our value is not one of the ones we see on the x-axis, but one is 620. First of all, where would that be? So you could see that falls between 609 and 640. So I could make a some type of dashed line, or somewhere around, I don't know, 620 would be somewhere between here. So this is our value of x equals to 620. So I'm just making an approximation. It is somewhere between 0 and 1. So if I wanted to calculate a z-score for this, then I can easily find the z-score using our z-score formula, which from the last video I showed you was the observation minus the mean over the standard deviation, or you can write it in words, and then let's see what our z-score is. But I can already tell from this model that it's going to be something between 0 and 1 because 620 is above the mean. So let's go ahead and see what we get. So our observation is 620 minus the mean, which is 609, over the standard deviation, which is 31. That is how we're going to calculate that z-score. So it's very simple math. I'm going to enter that into a calculator. So 620 minus 609 is 11. We get 11 over 31. And we want to know what our z-score is, so divide that by 31, and I have 0.35. So our z-score is 0.35, okay? So that makes sense because 0.35 is between 0 and 1. But the question asks what percentage of elephants are lower than 620. So basically what we want to know is the area under the curve to the left of 620 because they're asking us what percent is less than 620. So how would we calculate this area? Because we can't use the empirical rule since we have all this region that we don't know about. So how far, I mean, we can estimate it. I know that from the mean and below is about 50%, or is actually 50%. So all of this here, from here to here, is 50%. So how much would this be? Well, we have different ways to calculate that area. In this video, I'm going to show you using a z-score table. And in the next video, I will show you how to do that using our calculator. So let's go ahead and look at a z-score table. We already have our score. We know it's 0.35. So we want to know 0.35, the area under the curve from there. So if I would actually use notation, I can say, what is the area of x is less than 620? And by the way, this is equivalent as saying, what is the area with a z-score less than 0.35? Because 620 corresponds right here. If I can write a value here, 620, then that 620 corresponds to this z-score. So let's go ahead and look at a table and see what is the area below 620. Okay, so looking at a z-score table, first of all, they give you negative z-scores and positive z-scores. But one thing I want you to notice is it is always the area is read from left to right. Okay, so anytime you're looking for a z-score, it's always read from left to right. You can see the shaded region, but I'm going to go ahead and scroll to a positive z-score, and the score we want is 0.35. Okay, so you can see in the column here, let me just get a pen. You could see that right here in the column is listed our z-scores. They are listed all along this margin. So if I want 0.35, then I'm going to go to 0.3, which is right here. Okay, 0.3. And I'm going to go to 0.35. So I'm going to go across until I get 0.35, and this is going to give me the area under the curve. So I'm going to just label, this is the score I want, sorry, the area I want. So here is 0.05, and together 0.35. So if you can see, this is over to the second decimal space. So 0.35 is right here, and so the area I'm interested in is 0.6368. So that area is 0.6368. Let me write that down. So basically, we have found our area from the table is 0.6368. What does that mean? That means it is 63.68%. So that is our area under the curve, and we wish to find an area that is less than a z-score of 0.35. So looking here, let's see if that makes sense. I think that makes sense because we know from here to here is 50%. So all the way to 620 would be 63.68%. So what you want to do is answer always in context. So answer the question. You don't just want to show your work and give a percentage. You also want to write a sentence. So what percentage of elephants are lower than 620 days? I would write 63.68% of elephants are lower than 620 days.